let me show you this project. So here we are using this Tang 9K, a small FPGA. The good thing about this is you can actually store your program on the embedded this thing. And here I show you okay. So this is a small code which we have written where we have made a transmitter here, okay, which changes its frequency whenever I switch it on and off by using this particular pin. So the transmitted signal can be viewed from the pin number 82. Okay, so the pin number 82 is present here. So let me just remove this and I connect it to pin number 82, which is here. Okay, so this output you can view on the CRO, right? It produces a square wave. When I transmit, it generally produces that square wave. You can see it's in period around 20 microseconds. So now when I change the input, when I remove the input, you can see that the frequency also changes to 30 microseconds. So it's actually a switch which actually switches which is actually switching the frequency from 20 micro to 30 micro. You can see, you can view it from here. I hope this is visible. So when I plug it in, you have a different frequency. When I remove, you have a different frequency. Okay, so this is what is a small transmitter what we have made for the signal. And now what we have done to that, okay, so what we have done to that is this transmitted output we are actually connecting to a receiver, okay, which is an FSK receiver, which is nothing but a small PLL, okay, but because entire thing is digital here, so therefore the PLL what we are using is a digital PLL. So I have now connected the output of this to the input of my PLL. So now if you see the output of my PLL, that can be observed from pin number, you can see here, so it is pin number 71. So if I connect this to pin number 71, which is here, so this is the demodulated wave, okay, so not demodulated, this is the received wave output of the PLL, okay, so that is visible here. It's not good in shape, but you can see it's the output of the wave. Time period you can observe now almost the same, 20.27 microseconds. A little bit of shaky, okay, because digital it's quite complex. So now when I remove this, okay, now I go back and check it, I have a time period of 30. So my PLL is able to log to the incoming wave. If it's 20, my output is 20. If it's 30, output is 30. So it's simply tracking the input frequency. Now what we have done from here, okay, so what we have done is the low pass filter output of the PLL can be used for as demodulator, okay, so that can work as a demodulated wave. So we have done the same thing. So this is actually connected to an SPI DAC which is present here, and through these wires, and let me show you the SPI DAC output. You can see the output of low pass filter. You can expect it to be a DC signal. So you can see here, this is the DC signal which I have for my signal. So the moment I change the signal again, you can see, right, you can see the DC shifts. So you can see DC shifting, and that gives you an indication that there is a change in the frequency. Okay, so that means it's actually demodulating the wave. Let me show it from here again. I hope it is visible again. So when I provide first frequency, you have DC level going down for low frequency, and for high frequency DC level going up. Right. Now based on this particular DC value, what we have done is we have added this LED here. This LED, you can see based on that LPF value, it either glows or switches off. So if it is beyond some threshold, it's on. If it is less than that threshold, it's off. So this can be used for FSK demodulation. You can see here, the moment I change this, you get different frequencies. Okay, so that is our simple ADPLL transmitter, FSK transmitter receiver based on ADPLL. Okay, let me show you the changes again. Right.